To solve this root equation, I'm going to add x to both sides. And this changes the equation to the square root of x plus 6 is equal to x plus 6. Now that I have the square root on the left isolated, I can square both sides. The left side's nice. It's just x plus 6. The right side, you have to be careful. You do get x squared, the first term squared, and you do get 6 squared, which is 36, the last term squared. But you also have 6x, which you double to 12x. This will happen every time where you take the product of these two things and double it. That is the value that goes in the middle. So we have this expression here. To solve this quadratic, I'm going to subtract x from both sides. And I'm also going to subtract 6. My equation is now 0 is equal to x squared plus 11x plus 30. And the goal is to somehow, maybe use the quadratic formula or maybe even just factor this, if possible, into two pieces. Everything's going to be positive, and 5 and 6 multiply to 30 yet add to 11. This means I have two solutions. By looking here, I know x equals -5 as a solution, and so is x is equal to -6. The only thing I have to look out for is, do both of these numbers work in the original equation? So I'm going to check. Let's start with x equals -5. Will that work? Is the square root of -5 plus 6 minus -5 equal to 6? Is this thing a true statement? That's the square root of 1 plus 5 is 6. Is that true? And the answer here is yeah, because you do arrive at 6 is equal to 6. This is a true statement. -5 works. What if I were to try -6? Got to check that one too. That's the square root of -6 plus 6 minus -6. Is that equal to 6? Is this thing a true statement? That's the square root of 0 plus 6 is equal to 6. We're asking, is this true? And the square root of 0 is 0, so actually both of these solutions work in the equation. There are no extraneous solutions, therefore that's my answer for part A. Okay, I want to solve this quadratic equation, which I could try to factor. So there's a couple of ways to solve this. Either factor, make some guesses, or why not just use the quadratic formula? So I'm going to write that down. The solutions to ax squared plus bx plus c equals 0 come from -b plus or minus the square root of b squared minus 4ac, all divided by 2a. I just have to identify that a is equal to 2, b is equal to 11, and c is equal to 5. The solutions could come right from this formula. This is, one way to solve it. You could try factoring if you'd like, and there's nothing wrong with that. But using this formula, I get x is equal to -11 plus or minus the square root of 11 squared minus 4 times 2 times 5. And this is all divided by 2 times 2. Okay, that's -11 plus or minus. I'm going to do this portion under the square root directly in my calculator. 11 squared minus 4 times 2 times 5. And I get 81. You can break that up into a couple of steps if you'd like to, but I'm choosing it to just, put in my calculator. I'm not going to make a mistake. I don't think that way. So I get x is equal to -11, and hey, the square root of 81 works out perfectly to give us 9. This means we have two solutions. There's -11 plus 9 over 4, but also -11 minus 9 over 4. These will simplify. This is -2/4, which simplifies to -1/2. This one down here, this is -20 over 4, which is equal to -5. These are not extraneous solutions. These both must work in the original equation. The solutions are -1/2 and also -5. All right, so here we have another equation. I want to solve this thing for x, and the thing that jumps out to me is I think there's a greatest common factor that I can remove from both terms, and if this is possible, I would say do so. It might make solving this equation easier. There's a factor of 5 that can come out from both. That, by the way, kind of doesn't look like a 15, but that I'll rewrite it. That's supposed to be a 15. So you can take 5 out from both of those, and also x cubed. This means the expression above, it's equal to, I'll factor out of 5x cubed, and then I have to write down what is left over if I do. It's going to be an x minus 3. Because if you multiply this back in, 5 times this 1 is 5, x cubed times x to the first adds to x to the fourth. If you distribute this here, 5 times 3 is 15. X cubed with no x's to worry about here is just x cubed, and here I have a negative. So I factored this equation. The reason I'm doing this is I can now check to see where each individual factor is equal to 0. And clearly the one on the left only has one solution, 0. Whereas the second one is 3. 0 and 3 make the original equation true. One thing to point out is if you ever end up with a number, a single x, no plus or minus, to any positive integer power, it's always going to reduce to x is equal to 0 is the solution to this equation. All right, the goal for this equation, this rational equation, is to determine the least common denominator and multiply that to both sides. Let's see, I have a 3, a 4, and a 6. That means 12 is the least common multiple of those, but I also need an x. 12x would be my least common denominator. What I'm going to do is multiply that to each fraction in this equation. So that is, I multiply the left side by 12x, or 12x over 1, which first gives me this product. Then I have minus, again I multiply 12x over 1 to the next fraction, and that's equal to, if I multiply the right side by 12x over 1, I get this. The reason for doing this is, okay, 4 goes into 12 3 times, and the x's cancel. Perfect. My denominator is simply 1. I don't have to write it. In fact, I have 3 times 3, which is 9. Moving on. 3 goes into 12 4 times. Again, I can cancel these x's, and I'm left with just a 4 times a 2 in the numerator, which is 8. On the other side of my equation, 6 goes into 12 twice. I can't cancel the x. I'm left with 2 times x times 1, or simply 2x. The least common denominator made this equation simplify nicely. We have 1 is equal to 2x. The last thing to do is just divide both sides by 2, and we get our solution, that x is equal to 1/2. There's only one number that could not have worked in this original equation, and that's 0. If you put 0 in place of the x's, you would be dividing by 0, but we didn't get 0 for the answer down here, so this is the solution to the original equation. All right, here we are multiplying these two rational expressions, so the way we're going to do that is by factoring each expression first and then canceling common factors. Just a reminder, you can't just say, oh, I'm going to cancel this x squared into this x cubed. That you're not allowed to do that because these are not factors. We have this plus and minus sign. You can only cancel things that are connected by multiplication. So to see what I mean, I'm going to start by factoring the numerator of the left fraction. I see there's an x that I can take out of both terms, and it leaves me with x squared minus 4. Okay. It looks like we could potentially do a little bit more with that, but I'm going to hang on for a little bit. The denominator, well, that factors 2. That's got to be x and an x. You got to have a positive and a negative, and it is a positive 3 and a negative 2. Those multiply to negative 6, yet add to positive 1. In the numerator of the other fraction, the one on the right, I have an x and an x. Everything is positive. And if I use 1 and 3, the product is 3 and the sum is 4. Now in the denominator, Well, there's a greatest common factor of x squared that can be removed from both terms, and if I do, I'm left with x squared times x plus 5. I'm going to choose to write in another step here where I factor this piece. This is the only thing that is left unfactored. Everything else is fine. That's a difference of squares. I can break that into two pieces. There's no greatest common factor that you can remove, but if I put a -2 and a +2, the product is -4 and the sum is 0. That is equal to x squared minus 4. So just make a note here. This is a difference of squares. This is equal to x minus 2 times x plus 2. So we're talking about just this part of the equation. Well, anyway, just copying down everything that we previously figured out. That's x plus 3, x minus 2, multiplied by x plus 1, and x plus 3, divided by x squared and x plus 5. I can now cancel all of the common factors. Let's see. This x plus 3 cancels with that x plus 3. It replaces them with 1s. This x minus 2 can cancel with this x minus 2. Oh, okay, we can't cancel the x plus 5, the x plus 2, or the x plus 1, but this is an x to the first, and in the denominator we have an x squared. I can completely cancel this thing provided that this exponent drops down to a 1. If I copy down everything that's left over, in the numerator I have x plus 2, I also have an x plus 1. In the denominator I have an x as well as an x plus 5. There's nothing common that's left to factor, so this thing is my final answer. Okay, I'd like to factor this expression. So we're not solving an equation, we're strictly factoring. I can see that there's a greatest common factor that I could take out from each term. That appears to be a 2, as well as an x squared. If I factor out 2x squared, left over I have 6x squared plus 11x plus 3. You can check to see that this is correct by multiplying this back in, and it should take you to your previous step. But I'm done with the 2x squared. I now have to deal with the 6x squared plus 11x plus 3. You know, does this thing factor? Can I break this up into two pieces? That is, can I write this as 2x squared and then the product of two other things? To figure this out, let's work separately. I'm going to copy down 6x squared plus 11x plus 3 and try to figure out, does this factor? And it's kind of hard to guess, but I'm going to use a trick that we came up with in class. I take the first and the last number, which is 6 and 3, and I multiply them to give me 18. Then I look for two factors of 18 that would add to 11. So it might take a little bit of work. Factors of 18 would be, well, obviously 6 and 3, but 6 plus 3 doesn't add to 11, nor does 1 and 18, that adds to 19. The only other option would be using 2 and 9. If you add those together, it gives you 11, which matches up with this 11 here. In this situation, it allows you to factor the equation that we started with, provided that we copy it down like this. 6x squared, instead of writing 11x, I'm going to write 2x plus 9x. So again, using the 2 and the 9 to rewrite 11. And then I simply just copy down the 3. I then remove the greatest common factor from the first two and last two terms. Let's see what that does for us. Okay, when I do that, I can take out a 2 and an x from the first two terms, and I'm left with 3x plus 1. And if I take out 3 from the last two terms, I'm also left with 3x plus 1. I now have this greatest common factor of 3x plus 1 that I can remove another time. I factor out the 3x plus 1, and I copy down what's left over, which is 2x and 3. we just factored 6x squared plus 11x plus 3. I'm going to copy that down here. This is my final answer. So I'll just note that this is the final answer. And I put the work of factoring this expression off to the side. I'd like to solve this system of equations. We have two methods. There's substitution, or there's also the addition method. I'm going to use the addition method. So here's what I mean. I want to cancel either the x's or the y's by adding these two equations together. And the x's look a little bit simpler. Here's what I mean. If there was a 2, a negative 2x here, and I added these two things together, you would cancel all the x's. There would be 0 x's left. But there isn't a 2. Well, I'm going to multiply both sides of this second equation by 2. There'll be a 2 here, and then when I add those two equations together, it cancels. So there's a middle step where, okay, I'm not going to do a thing to my first equation, which was 2x plus 5y is equal to 2. I'm just going to make a note that we're going to take this second equation and we're going to multiply it by 2. If you do that, you get negative 2x plus 12y is equal to negative 36. This is a great option for solving this system because if I now take these two equations and add them together, you cancel the x's. 5y and 12y is going to be 17y. And then we have 2 plus a negative 36 is negative 34. This makes it very easy to solve for y. I can simply take this equation and divide both sides by 17, and we arrive at y is equal to negative 2. The only thing that we don't know is the corresponding x value. But we can take any equation that has both an x and a y, plug in negative 2 for y, and solve for x. So I'm going to go back to the equation negative x plus 6y is equal to negative 18. I'm going to take this value and put it in place of y, and then come over here and solve for x. Negative x plus 6 times negative 2 is equal to negative 18. Or negative x minus 12 is equal to negative 18. If I add 12 to both sides, I get negative x is equal to negative 6. Dividing both sides by negative 1 gives me my final answer for x equal to 6. So I have my solution. I know that x has to be equal to 6 and y has to be equal to negative 2, and I solve for this by using the addition method. For question 5, we are going to eventually find the equation of a line going between these two given points, as well as determine its x and y intercept. Starting with part A, I ask for the slope between these 2 points, and you have to know this formula for slope, and actually also know the formula for the equation of a line. We'll be using this one first, but I just have to label one of my points as x1, y1, and the other as x2, y2. It does not matter the order in which you choose them, so I'll say, I guess this is x1, y1, and this is x2, y2. My slope, therefore, is going to be y2 minus y1, that's negative 4 minus 14, all over x2, which is 2, minus x1, which is negative 4. Being careful, there's a minus in the denominator. The numerator is negative 18, and then the denominator is positive 6, because it's really 2 plus 4. I just figured out my slope, and that is negative 3. Now, part B is asking for where does this line cross the y-axis? Use this to find the equation of the line. So I'm going to copy down the equation of the line. And note that we've actually just already figured out m. It's negative 3. I'm going to put that information into my equation. The only thing that I don't know is b. That's the y-intercept, or where the line crosses the y-axis. To solve for b, I can use either this point or this point and substitute it into this equation. I'm going to choose this point just because the values are smaller. You could have used negative 414 as well. But essentially, I'm going to this equation, and wherever I see x, I put 2, and wherever I see y, I put negative 4. So that is, negative 4 has to be equal to negative 3 times 2 plus b. The only thing I don't know is b, but I can solve for it. It is equal to, after I add 6 to both sides, 2. All right, I just answered part b. Y is equal to negative 3x plus 2. 2 is the value, the y value, of where the line crosses the y-axis. Okay, last part, C. Determine where the line crosses the x-axis. We're asking for the x-intercept. Since we have an equation for our line, this is a very easy thing to do. You take your line and you set it equal to 0. Whatever x value we end up with is the x-intercept. I can subtract 2 from both sides, divide both sides by negative 3, and I have my solution. X is equal to 2/3. Maybe I'll put, just a note that I subtracted 2 from both sides as my first step. If you're being picky, maybe I should be, we just found the point 2/3 comma 0. 2/3 for x corresponds to 0 for y. That's the x-intercept. Whereas in part B, the y-intercept was 0 comma 2. So that's the y-intercept. This is the x-intercept. And that is it for this problem. And for this last problem, question 6, we're doing some polynomial division. To solve this using a long division algorithm, you have to write the x plus 5 outside of this division symbol with the original polynomial underneath it. The goal is to cancel this 2x cubed by multiplying something to x plus 5. So that must mean I'm going to multiply by 2x squared to get a 2x cubed. So I'm going to place that right here. 2x squared times x is 2x cubed, and 2x squared times 5 is 10x squared. I now subtract the thing that I just put there. So again, I want to match up right here 2x cubed, so when I subtract it, I get 0. This was for me to decide to say, okay, well, if I have an x here, I'd have to multiply it by a 2 to have a 2 here, and x squared times x gives me x cubed. That's how I arrived at 2x squared. But you also have to multiply this to the 5. 2 times 5 is 10. There are no x's, so the x squared is tagged along. That's how I got this expression that I'm now going to subtract. And when I do, I have 7x squared minus 10x squared. That's negative 3x squared. And I now bring down the negative 7 and repeat this process. I want to have a negative 3x squared here. What do you multiply x by to get negative 3x squared? And the answer is negative 3x. Because negative 3x times x gives me negative 3x squared. I'll write that here. And negative 3x times 5 is negative 15x. I now subtract the thing that I put here, which is great. This minus a minus is a positive, so the negative 3x squared plus 3x squared is 0. Here I have negative 7x plus 15x. That leaves me with 8x. And then I'll bring down the plus 40. I'm at my last step. I want to cancel an 8x, so I'm going to multiply by 8. Because 8 times x gives me 8x, and 8 times 5 gives me 40. In fact, this works out perfectly. I get the exact same thing sitting here. So when I subtract it, I get a remainder of 0. So we just divided these two polynomials. We ended up with a remainder of 0, and the answer is 2x squared minus 3x plus 8.